Have you ever bitten into your favorite snack, maybe poured a drink, and just noticed it tastes exactly the same?
Every single time.
Yeah, every time, no matter where you buy it, when you buy it, that consistency, that perfect crunch or that exact flavor.
hmm
Is that just like pure luck, or is there something more complex going on behind the scenes?
It's fascinating, isn't it?
Yeah.
But no, it's definitely not luck.
Okay.
That kind of perfection, that reliability, it comes down to some really rigorous quality testing.
Ah,
So for this deep dive, that's our mission, really, to explore the cutting edge science and tech that food companies use.
to make sure everything's perfect.
Exactly.
Yeah.
Perfect, consistent, and safe. All the way from the farm, basically, right to your kitchen table.
Okay, let's get into this then. So before we even talk about fancy machines and labs, I was surprised to read the human element is still key.
Oh, absolutely vital. Yeah. Manufacturers rely heavily on what they call sensory panels.
Sensory panels, right. So these are like expert tasters.
Highly trained experts, yes. It's not just casual tasting.
I bet. I mean, what does it take to become one? What are they actually testing for?
Well, it's incredibly precise work. These panels, they test everything. The taste profiles, for starters.
Making sure it matches the brand's signature flavor?
Precisely. It safeguards the product's identity. Imagine if your favorite soda suddenly tasted different depending on where you bought it.
Yeah, that would be bad for the brand. Big time.
Huge. So these panels prevent that. They also check texture consistency. Is it crispy enough, smooth enough?
Any feel?
Exactly.
Mm.
And even aroma. How strong is the scent? How does that impact the taste?
Huh. I never really thought about the smell being scientifically tested like that.
Oh, yeah. And the testing itself is scientific. It happens in really controlled environments.
Oh, so.
Think specific lighting, exact temperatures, even filtered air. It's all about removing bias, ensuring their palates are like uh, finely tuned instruments.
Wow. Okay, so humans are the first line of defense, these super tasters.
Mhm.
But what about threats you can't taste or see? The hidden dangers? How do companies find those?
Right, and that's absolutely critical. That's where we move into the lab, into the microscopic view.
Okay, the high-tech stuff.
Yeah, this is where scientists perform really advanced tests. They do microbial analysis, for instance.
Looking for bacteria and things.
Exactly. Bacteria, yeast, mold growth, detecting those invisible threats before they can cause any problems. It's constant vigilance.
Makes sense. What else?
Then there's pH testing, making sure the acidity is right within safe levels.
Okay.
And really importantly, measuring something called water activity.
Water activity. Is that just moisture content?
It's related, but more specific.
Mhm.
It's about the free water available for microbes to use. By controlling that, you basically starve potential spoilers.
Ah, so you stop bacteria and mold from growing by controlling the water they need.
Precisely. It dramatically extends shelf life, often without needing lots of preservatives.
That's clever. So safety is covered microscopically. But back to that feel the crunch of a chip, right? Or
Mm.
how a sauce pours. Is getting that right just as complex?
Oh, absolutely. It's serious engineering, texture engineering, you could call it.
Okay. How do they engineer texture?
They use specialized tests. For liquids like sauces or dressings, they run rheology tests.
Rheology, what's that measuring?
It measures flow and viscosity. Think about getting ketchup out of a bottle, not too thick, not too thin. Rheology tests nail that perfect consistency.
Right, right. Okay, so that's liquids. What about solids like cookies or crackers
For those, they use compression tests.
to see how they break?
Exactly. That perfect snap you expect from a cracker or the crumble of a cookie. Too hard or too soft, and it's just not right. Compression tests ensure it breaks just the way it should.
Huh. Never thought about the break being engineered.
And then for frozen foods, there's freeze-thaw stability analysis.
Why is that needed?
Well, have you ever had ice cream that got icy after refreezing? Or a frozen sauce that separated when thawed?
Yeah, definitely.
These tests make sure the product's structure, its texture, holds up through those temperature changes, from their freezer to yours.
It's amazing how many layers there are to this. So looking forward, what's next? Any cool innovations coming in food quality control?
Yeah, the future looks pretty exciting, actually. We're seeing more AI getting involved.
AI.
AI-powered inspection. Machine learning algorithms that can spot tiny flaws or inconsistencies, maybe even better than the human eye over time.
Interesting.
Then there's blockchain technology.
For food, like Bitcoin.
Sort of, but for tracking.
Mm.
It creates a secure, transparent record. You could trace ingredients right back to the specific farm. Total traceability and authenticity.
Wow, that's transparency. Anything else?
And smart packaging. Imagine labels that change color to show you very clearly how fresh the product is.
That would be useful.
Definitely.
So wrapping this up, what's the big takeaway here? It sounds like food quality is way more than just taste.
Oh, much more. It's this whole engineered system, really.
Yeah.
Focused on perfection, yes, but also consistency and, crucially, safety.
So the next time you grab that favorite snack,
Mm-hmm.
just remember, it's probably been tested for hundreds of different things, designed with incredible precision before it even got to you.
Exactly. And it kind of makes you wonder, doesn't it? This whole deep dive, it just shows how much invisible science is behind everyday things.
Yeah.
So maybe the question to leave you with is, what other simple, consistent things in your life are actually the result of these incredibly complex, rigorous processes working away silently, just making sure everything works?